Good day, class. Let's look at mathematical induction. Mathematical induction. What is actually this mathematical induction? Mathematical induction is one of the techniques which can be used to prove variety of mathematical statements which are formulated in terms of n, where n is a positive integer. So in that case, we're going to take our n to be element of n, where this n is actually called the set of natural number, and this n here is an element, that is a member of this positive integer. Now let's formulate let's have a formula of let's just say let's have 1 plus 2 plus 3 plus up to n. Let's just say is equal to s subscript n, and then let's have n plus n minus 1 plus n minus 2 up to 2 up to 3 plus 2 plus 1 is the same thing as Sn. So if you have these equations, let's add this equation together. So we have 1 plus n will give us n plus 1. Then 2 plus n minus 1 will give us n plus 1. And also 3 plus n minus 2 will give us n plus 1. So if you continue that way, we're going to have up to n plus 1, all equal to 2 of s of n. So at this point, we're going to have n plus 1 plus n plus 1 up to n plus 1, and this is up to n times. So this is the same thing as n into n plus 1, which will give us 2s of n. Now we're going to make this s of n the subject of the formula. If you do that, we're going to have, therefore, that s subscript n will give us n into n plus 1 all over 2. So in this case, we have established that 1 plus 2 plus 3 plus up to n will give us n into n plus 1 all over 2. So we're going to use mathematical induction to also prove that this formula is actually correct. So how do you prove that? We're going to take when n is 1. So if for n equal to 1, we're going to have that the left hand side is actually the first term, which is still 1, which is equal to 1. So in this case, we have that p of 1 will give us 1 for the left hand side. Also, for the right hand side, which is coming from n into n plus 1 over 2. So when n is 1, we're going to have 1 into 1 plus 1 over 2, which will give us 2 over 2, and 2 over 2 is actually 1. So in that case, p of 1 is actually correct. So that is to say that p of 1 is equal to 1, since the left hand side equal to what? The right hand side. So that is the first step. Then the second step we are going to take is that we are going to assume that for n equal to k, we're going to assume that this is also correct. This is true. That is to say that 1 plus 2 plus 3 plus up to k, then this is equal to k into k plus 1 all over 2. So you can call this equation 1. So at this point, then our job now is to show that n equal to k plus 1 also holds. So how do you do that? We're going to use equation 1 and then we prove the remaining. So you say for n equal to k plus 1, so we're going to have that left hand side is going to give us 1 plus 2 plus 3 plus up to k. Then after k is what? K plus 1. But from here, the whole of this from equation 1 is equal to k into k plus 1 all over 2. Then we have plus k plus 1. So at this point, we're going to simplify the right hand side. What is that right hand side? Therefore, the right hand side, so we're going to have that the right hand side will give us k into k plus 1 all over 2, then plus 2 into k plus 1. That is finding the LCM, and then simplifying, we're going to have k into k plus 1 plus 2 into k plus 1. And what is common? What is common is k plus 1. So at that point, we factor out, we're going to have k plus 2 into what? K plus 1 all over 2. So in this case, we can actually have that the final answer for the right hand side is going to give us, so you see the right hand side now becomes k plus 1, then plus 1, then plus, that is after that, then you say into k plus 1, then divided by 2. So obviously, this is our n when n is k plus 1. This is also what? This is also our n when n is equal to k plus 1. That is, this is equivalent to what? This is equivalent to n into n plus 1 all over 2, which is actually the left hand side. So we have actually proved that n into n plus 1 over 2 when n is equal to k plus 1 is also correct. Therefore, you can see that the left hand side equal to what? The right hand side. That is for n equal to k plus 1 is also true. So what do you conclude? You say that for n equal to k is correct, and since we have assumed that, and we have already used that to prove that n equals to k plus 1 also correct. So in general, we say that P of n is true for all n in n. So this is how to prove using a mathematical induction. Thank you. Please subscribe to my YouTube channel for more videos.